Hello, this is kind of an overview or a summary day of the three forms for graphing quadratics. Just as lines had different forms for graphing them, you had slope-intercept form, y equals mx plus b. You had point-slope form that communicated to you a point, not necessarily the y-intercept and the slope. Quadratics have the same feature. They have different ways to rewrite their equations, and each way has its own pros and cons. And so we're going to look at those today. So today's topic is on comparing the three forms to graph quadratics. We're going to look at them one at a time. Let's look at standard form first. So if I look at standard form, that's anything of the form ax squared plus bx plus c. That's where everything is all expanded out in expanded form is what you'll also hear this, but standard form is the more common. The benefit of standard form is it tells you the y-intercept because everything is multiplied out. You can see the c term at the end. That c term is going to be your y-intercept. The a out front will tell you how the graph is going to open, either upward or downward. So that's the pieces of information you get just looking at standard form for quadratic. An example would be y equals negative x squared plus 4x plus 5. If I look at this, what do I know? I know that the graph has a y-intercept at 5, so it's going to have a y-intercept at 5. And the only other thing I know is I know that the graph is going to open downward. That's it. I don't really even know if it's on the left or the right side of this. I just know it's going to open downward. So it looks something like that. What are some things I don't know? I have no clue where the vertex is. I have no clue where the x-intercepts are. That's the downside of standard form, is I need to do more work in order to get those pieces of information. But standard form will tell you where the y-intercept is. Second form is called factored form. It's factored form because we've taken something in standard form and factored it to get the factors of the equation. The benefit of factored form is it tells you where the x-intercepts are. The x-intercepts for this would be at positive m and positive n. The benefit of factored form is just like standard form. The steepness factor up front will tell you how the graph opens. That's the one thing that they all have in common. They all will tell you how the graph opens. That's the one thing that they share, besides being a quadratic. An example of one in factored form would look like this. Y equals 2 times the quantity x plus 7 times x minus 3. If I look at this just the way it is, and I were going to sketch a graph in my mind of what it really is looking like, I know that the intercepts are going to be at negative 7. So over here at negative 7, what would make this one be 0 if x equaled 3? And then I know because this is a positive 2 out front that the graph is going to open upward. So it'll look something like that. What are some things, again, that I don't know? I have no clue where the vertex is, and I have no clue where the y-intercept is. I would have to do more work to get there if it was in vertex form. Or sorry, in factored form. The last form that we're going to look at is vertex form. Just before I leave, benefit of factored form is it tells you the x-intercepts. It will not tell you the y-intercept or the vertex. Last one, vertex form. The benefit of vertex form is it obviously will tell you where the vertex is. That's why we call it vertex form. And like all the others, the steepness factor out front will tell you how the graph is going to open. If you need to pause the video to fill that part in, go ahead and do so. I'm going to assume that we're good. An example of one in vertex form is y equals 3 parenthesis x minus 2 squared minus 4. If I look at this, I know that the vertex is going to be right 2, past 2, and down 4. So right 2 and down 4. So right 2 and down 1, 2, 3, 4. So it'll be something like here. I do know the graph opens upward, and it's going, what, up 3 and right, so 1, 2, 3 and right 1, up 1, 2, 3 and right 1. If I sketch the graph in, it's going to look something like that. That's awful. It's too straight. It's more curved. I don't know why I can't do that. Something like that. Curving on that side a little bit. There we go. So something like that. What are some things I don't know? I have no idea where, again, these x-intercepts are. And I have no idea where that y-intercept is. All I know for vertex form is the vertex. And that is a summary of the three forms. They each tell you different pieces of information. It just depends on what you would like to know. So to talk about, because a lot of the time this gets used when talking about projectiles, anything moving through the air. Standard form will tell you the y-intercept, that's where it took off from, that's where it started. So if you want to know where something was shot from, you would use standard form. Factored form tells you where it landed, is the biggest one, is where it landed, or if it was shot from the ground, where it was shot from the ground. But factored form tells you the x-intercepts, which is going to be if it's opening downward, where it lands. Vertex form is going to tell you the vertex, which if it's opening downward, the vertex will be at the highest point. So vertex will tell you the maximum height. So vertex, maximum height. Factored form will tell you where it landed. Standard form will tell you where it took off. So that's the benefit of each type of form. Let's practice looking at them, identifying which form they're in and what pieces of information that we get. So if I looked at the following equation and I looked at my key, I see it's all expanded out. That is in standard form. If you're in standard form, what you get is you get to know the y-intercept. So the y-intercept is at 0, 8. And I see because this is a -3 out front, I know the graph opens downward. That's all that I know. That's it. Second one, what form is that in? That is in vertex form. It's written with a square term in parentheses. So this is in vertex form. If it's in vertex form, you better tell me where the vertex is. The vertex is at right, so past 10 and up 7. And because this is a 1/4 out front, the graph opens upward. You could also say maybe it's wider too, a little wider, but opens upwards kind of the key part. Last one, that is written in factored form. Two clear factors, factored form. If it's in factored form, you better be able to tell me where the x-intercepts are. The x-intercepts are going to be located, this one would be if x equals a +8, then y would be 0. And if x was a -2, then y would be 0. The other thing is there's a 1 out front. Don't forget, because there's a 1 out front, that's positive. This graph is going to open upward. There's an example of all three type of forms being shown. Here's your chance to try for yourself. Do exactly what I just did. State what form it's in and what piece of information you get from that form. So pause the video now, unpause once you've had a chance to try. Okay, let's go over it. First one, vertex form. I'm going to go kind of fast. The vertex is located at -3 and 9, and because it's negative out front, you know the graph is going to open downward. This is in factored form. The x-intercepts are going to be at -6, 0, and 4, 0. And because it's a positive out front, oh, oopsies, I wrote the info here. I need to say what form it's in. I said it, hopefully, but I didn't write it. It's factored. X-intercepts are at -6, 0, and 4, 0, and then the graph is going to open upward because it's positive out front. Last thing is we're going to practice graphing them. So depending on what form they're in, pull out the information in order to graph it. So the first example, this is graph in vertex form. It's written in vertex form. The vertex is past 1, up 4. So right 1, up 4. The steepness factor out front is a -2. So I know it's going to open downward. I go down 2 and right 1, and I get the right side of this graph. And once I have the right side, I can reflect to get the left side. And I'm done. And that is graphing in vertex form. Pretty quick. That's the benefit of vertex form. This one is actually, I believe, a combination of the two. It starts by graphing in standard, but if you're given something in standard form, you should always see if you can get to factored form, because then you have x-intercepts and you have more pieces of information. And this one you can. I'm going to start by saying, okay, I know it's in standard form. Let's see if we can get to factored form to figure out the x-intercepts. What numbers multiply to be 12 and add up to be 8? It's 6 and 2. Once I have the x-intercepts, which are going to be, so step 1 is factor it, which I already did, right there. Now I find the x-intercepts, so factored was x plus 6, x plus 2. The zeros, or the x-intercepts, are going to be when y is equal to 0. And y will be equal to 0 when x equals -6 and -2, so -6 and -2. That's where the x-intercepts are. We've practiced this enough by now that I hope you recall that the vertex is going to be halfway in between, and halfway between -6 and -2 is -4. If you don't see that, you have to add those numbers together and then divide by 2. You need to find the average. In order to get the y-coordinate, you put -4 in for x in the equation. If you need a review of this, you can go back and check any of the lessons that we said graph by factoring is a whole overview of what we're doing right now pretty quickly. Plus 8 times -4 plus 12. That's going to be 16 minus 32, which would be a -16 plus 12. That would be a -4. So -4, -4 should be where the vertex will be located. And then the last part is the standard form. Because it's in standard form, we know where the y-intercept is. It's at 12. So it's right up there. I sketched the right side, mirror image on the left side, and that one shouldn't curve back like that. So right, where is this? Here? Something like that. That looks better. And that is graphing in standard and factored form. We should have written the y-intercept was at 0, 12. So if you're given something in standard form, see if you can get it into factored form, because then you get more pieces of information. That is it. Thank you very much and have a good day.